In this 88K video, we're going to wrap up the WIO demo board with looking at the assembly and the soldering of the components and the wire wrap and some of the other tips that you'll need to complete your build. So let's get to it. Okay, so here we are at the assembly segment. Now what we're going to do is look at the basic fundamentals. I'm not going to go in and solder everything. I'm just going to kind of show you a couple of the techniques that you can use, or some of the methods that help to make things a lot easier. So now here are the three assemblies, the two the Pi Pico and then the two Darlington transistor arrays. Now trying to solder these things are pretty much a bear, but you can use this roll of tape and then also the perf board here. And with this perf board, you can place it on the tape, then you can put the pins here on the perf board, and then you can connect, or you can just set the board here on top. And let's see, one more. And now that will hold the Pi in place, and then you can solder each corner and tack it down. You can use a little bit of tape to hold it down to make it actually flush, and the more it's flush, then the straighter the pins will be. And then once it's soldered, then you'll be able to just place it on the board itself. You can do the same thing with the perf board. You can set it up in the same way here and just place it on the board, and then once it's on the board, you solder the four corners, and then you can put the chip on. Now, one thing for sure, pay attention to the position. There's a little notch here on the chip that shows pin number 1, and then you match it up on the board. And what you can do is you can put a little bit of the solder paste onto the pads, and then the paste will actually hold the chip in place. And once you place the solder on, it will wick down, and then the chip will actually go in place and position itself based upon the tension, I think they call it. Now, once that's done, then you have all the boards completed, or the assemblies completed. Now, the next thing is when you place the assemblies on the board, what I did, and then here's one that I did partially so you could see. So if you look at each one of the corners, you can see that they're shiny. That's because I placed solder here on each corner to actually hold the chip in, or the assemblies on. So now what you want to do is just put just a little bit of solder on there, just for it to wick down into the little holes, and that way it doesn't interrupt the wire wrap process. So that's an easy and good technique. Now let's talk about the wire wrap. So here's the wire wrap tool. This is a OK Industries. Now you can get knockoffs. The problems with the knockoffs, they're a lot cheaper, but it's the quality, the construction. Once you start to kind of welch on that, then things can go downhill. Now this right here is a stripper, and you stick the wire in and then pull it, and that's how you strip the wire itself. Then what you do is you place the wire inside, and then once it fits over the pin, you just twirl it, and as you twirl it, then it wraps around the post. Now here is another alternative, and this is the wire wrap gun. And the one bad thing about the wire wrap gun is the price. The gun itself is like $130 to $170. Then the post, or not the post, but this is called the sleeve. The sleeve is like $60, and then the bit inside is another $60. So you're almost looking at $250 to $300 for this. And now you can see when you squeeze the trigger, this just rotates around, and that's how it gets the wrapping motion. So you kind of have to use this wire wrap method, because trying to do the solder trace, what they typically do on the board, isn't possible because of the actual number of connections that you have to do. And you kind of want to use this 30 gauge wire, because a larger wire just starts to make it more bulky. And you can solder this in as well, but that is going to take a little bit of the technique of being actually to put the solder down and then just touch it without bridging the connections. So this is just one way. I'm sure there's other guys doing other, they have other means of making this, but I kind of found this to be the easiest and then the most kind of organized way of doing it. So here, then this is the distribution board itself. The sensors here, they have the 3 pins, and these are 3-pin connectors. Now you have the power that goes to the positive and negative that goes to the board, and then the one sensor lead that comes back. And now that's what I did here with the brown leads are the sensor leads, and then you have the plus and minus. So I created a pad here, and I kind of made it like a terminal block, and then that's where you got single power in, and then the distribution to all 8 of the ports. So this is what I kind of used. Now on the other board, original board, I used 2 of the what do you call it? Auxiliary connections, and this was more so the auxiliary connection. This is the main connection, but then on the next board I just omitted that, so because I won't be using that, it's not worth it. So here we go, and I think that pretty much sums it up. Then here's the that ribbon cable. So I made the ribbon cable. I had these 10-pin connectors, and then this is just from a big long ribbon cable that had for the jumpers for the breadboard. So, and then I just doubled them up. So that's how I made these. So that pretty much ends it, and I think the build's pretty much simple. It's a little bit difficult and whatnot, but there's no doubt you guys can do it. So as usual, subscribe, like, and share, and we'll talk to you later. Bye.